Cockpit Video 9. The cockpit is truly the brain of an airplane, the place where pilots control every moment of flight from takeoff to landing. It's a highly advanced environment filled with instruments, systems, screens, and communication tools that work together to guide a massive jet safely through the sky. Today, we're going to explore what happens inside the cockpit, how pilots use different instruments, and why modern aircraft rely heavily on advanced technology to ensure safety and efficiency. When you first look inside a cockpit, it may seem overwhelming: dozens of screens, hundreds of switches, and countless buttons. But every part of the cockpit has a specific purpose, and pilots are trained to understand and manage them. The central role of the cockpit is to provide information and control over the aircraft's movement, systems, and navigation. Everything a plane does, climbing, turning, cruising, descending, starts with pilot inputs from this very space. Let's start with the primary flight instruments, the essential tools pilots use to control the plane. One of the most important is the altimeter, which tells pilots how high the plane is flying above sea level. Altitude is crucial for safe separation between aircraft and for navigating through controlled airspace. The airspeed indicator is another key instrument, showing how fast the aircraft is moving through the air. Maintaining the correct airspeed is vital for takeoff, stable flight, and preventing stalling. Next is the attitude indicator, often considered the heart of the instrument panel. It shows the orientation of the airplane relative to the horizon, whether the plane's nose is pointing up, down, or if the wings are level. This is essential when flying through clouds or at night when external visibility is limited. The heading indicator tells pilots the direction the airplane is pointing, working like a more precise version of a compass. Combined with navigation systems, it helps pilots stay on the correct course. Modern cockpits feature electronic flight instrument systems (IFIS), also known as glass cockpits, where digital screens replace old analog dials. These screens display flight data more clearly and can be customized by the pilot, improving situational awareness tremendously. Aircraft like the Airbus A320 and Boeing 737 MAX use multiple large displays that show flight path, engine performance, weather radar, navigation routes, and system warnings. Navigation is another critical cockpit function. Pilots rely on a variety of tools, including GPS, VOR beacons, and inertial navigation systems to determine their exact position in the sky. GPS provides global accuracy, while VOR stations on the ground help planes follow specific airways. INS systems track movement even without external signals, ensuring aircraft remain on course during long flights over oceans or remote areas. One of the most powerful features in a modern cockpit is autopilot. Contrary to what many people think, autopilot doesn't fly the entire plane automatically without pilot involvement. Instead, it helps maintain altitude, heading, airspeed, and navigation routes with incredible precision. Pilots program the flight plan into the FMS flight management system, which works with the autopilot to guide the aircraft. During long flights, autopilot reduces pilot workload, helps manage fuel burn, and ensures smooth flight performance. But the pilots always remain in control and ready to take over at any moment. Communication is another vital task managed from the cockpit. Pilots constantly communicate with air traffic control (ATC) using radio systems. These radios help coordinate takeoff clearance, altitude assignments, route changes, and landing instructions. Clear communication ensures that all aircraft maintain safe separation and follow proper procedures. Modern aircraft are also equipped with ACARS, a digital communication system that sends messages between the aircraft and airline operations centers. Cockpits also contain systems that provide information about the weather. Weather radar shows pilots where storms, turbulence, or heavy rain may be encountered on the route. This helps them navigate around dangerous weather patterns. Some airplanes even use predictive wind shear and turbulence detection tools that alert pilots in advance, making flying much safer. Another important area of the cockpit is the overhead panel, which controls the airplane's electrical systems, fuel pumps, hydraulics, air conditioning, lighting, anti-icing systems, and engine start functions. Pilots must monitor these systems constantly to ensure everything is functioning normally. During engine start, for example, pilots follow a checklist to verify airflow, fuel supply, ignition, and engine stabilization, all done through the overhead controls. Speaking of checklists, they are a major part of cockpit operations. Pilots use detailed checklists before taxiing, before takeoff, during climb, during cruise, before landing, and even after shutting down the aircraft. These checklists ensure that no critical step is overlooked. Even the most experienced pilot in the world relies on checklists because aviation safety depends on precision and consistency. Cockpits are designed with ergonomics in mind. Everything is placed within easy reach of the pilots, with the captain sitting on the left and the first officer on the right. The control column or side stick allows direct control of the aircraft's pitch and roll movements. Rudder pedals control the plane's yaw and help steer on the ground. All controls are designed for quick and accurate response. In the past, large jets required a 3-person crew, captain, first officer, and flight engineer. But with modern automation and advanced systems, most airliners today operate with just 2 pilots. Despite this, the workload during critical phases, especially takeoff and landing, remains, demanding pilots work together, sharing responsibilities, cross-checking instruments, and making decisions to ensure a safe flight. The cockpit truly represents the highest level of human and technological cooperation. It takes decades of engineering to create a system that pilots can control with precision and confidence. From the flight displays to navigation systems to autopilot, each part of the cockpit plays a vital role in making air travel the safest mode of transportation. Now that we've explored the cockpit, the next video will uncover the science of aerodynamics, the invisible forces that allow aeroplanes to stay in the air.